Good morning, mom. Good morning, classmates. So, our report is all about the periodic table. The periodic table is an arrangement of all elements known to man in accordance with their increasing atomic number and recurring chemical properties. They are assorted in a tabular arrangement wherein a row is a period and a column is a group. The objectives of this report is to be able to identify groups and periods in the periodic table, to know the positions, properties, and uses of the halogens, to know the positions of group 1, group 0, and group 7 in the periodic table. Materials, a periodic table of the elements and the references in chemistry. The periodic table has 7 horizontal rows or periods. The first period consists of hydrogen, which it can be seen at the top of the table above the first column, and helium on top of the last column to the right. The second period begins with lithium and ends with neon. The third period begins with sodium and ends with argon. How many elements are there in this period? There are 8 elements in this period.
How many elements are there in this period? There are 8 elements. The periodic table has the following vertical columns called families or groups: 8A groups and 8B groups. The group B elements differ from the rest because they are heavy metals. Elements with atomic numbers 57 to 71 forms the lanthanide series or rare earth elements, while those with atomic numbers 89 to 98 forms the actinide series or radioactive elements. What is meant by rare earth elements? The rare earth elements is a group of chemically similar metallic elements comprising the lanthanide. They are not specially rare, but they tend to occur together in nature and difficult to separate from one another. Scandium and yttrium are sometimes known as the rare earths since they were first identified as rare minerals alongside the lanthanides and separated as oxides or earths. These metals are collectively known as rare earth elements. What is meant by radioactive elements? Radioactive elements are made up of atoms whose nuclei are unstable and give off atomic radiation as part of a process of attaining stability. They are not specially rare, but they tend to occur together in nature and are difficult to separate from one another. When an atom receives enough neutrons, it becomes unstable and decays. Tritium, a radioactive hydrogen isotope naturally occurring at extremely low quantities, is a good example of this. The 8 A groups are further divided into 3 subgroups. How do group 1A and group 2A differ from the other group A elements? Well, they differ from the other group A elements because the group 1A are alkali metals and the group 2A are alkaline earth metals. Why is hydrogen separated from the rest of group 1A? The hydrogen is separated from the rest of group 1A because hydrogen is not a metal but a gas. How do group 3A to group 7A differ from the other group A elements? Group 3A is the boron group and the group 7A are halogens.
Number 9. The group 8A elements last common to the right are helium, neon, argon, krypton, xenon, and radon. They are inert gases mentioned in your books. H. What is meant by inert gas? An inert gas is a gas that does not form chemical reactions with other chemical substances and therefore does not form chemical compounds. Letter I. Select one inert gas. Refer to the chemistry books on the following information. A. What are its general characteristics? Neon, colorless, tasteless, odorless, chemically inactive, changes reddish-orange in vacuum tube, and lowest liquid range. B. Where it is found in nature. It is found in very small traces in both the Earth's atmosphere and the Earth's crust. Number 10. The elements on the left portion of the chart, those located to the left of the thick zigzag line, are metallic. Letter J. Give 5 common characteristics of metals. A. High melting points. B. Good conductors of heat and electricity. C. Malleable. D. High density. E. Ductile. 11. The elements on the right portion of the chart, those located to the right of zigzag line, are non-metallic. Letter K. Give 3 common characteristics of nonmetals. A. Poor conductors of heat and electricity. B. Low melting points. C. Brittle. Number 12. The elements which border the zigzag line behave like metals or nonmetals under different conditions. They are called metalloids or amphoteric elements.
In the empty boxes, write down the first 20 elements starting with lithium, proceeding from left to right, row by row in order and increasing atomic numbers. Chemical symbols, atomic number, atomic mass, and physical properties. 2. Atomic number is 3. Atomic mass 6.941 grams per mole. Melting point is 180.54 degrees Celsius. Boiling point 1342 degrees Celsius. Density 0.534 grams per cm3. Helium. Atomic number 4. Atomic mass 0.012 grams per mole. Melting point 1237 degrees Celsius. Boiling point 2500 degrees Celsius. And density is 1.25 grams per cm3. Boron. Atomic number is 5. Atomic mass 10.811 grams per mole. Melting point 2075 degrees Celsius. Boiling point 7232 degrees Celsius. Density 2.34 grams per cm. Carbon. Atomic number 6. Atomic mass 12.0107 grams per mole. Melting point 3550 degrees Celsius. Boiling point 4807 degrees Celsius. Density 1.597 grams per cm. Nitrogen. N. Atomic number 7. Atomic mass 14.007 grams per mole. Melting point 209.86 degrees Celsius. Boiling point 195.8 degrees Celsius. Density 1.0 grams per cm3. Atomic number 8. Atomic mass 15.999 grams per mole. Melting point 218.79 degrees Celsius. Boiling point 182.962 degrees Celsius. Density 1.41 grams per cm3. Fluorine. Atomic number 9. Atomic mass 18.998 grams per mole. Melting point 219.62 degrees Celsius. Boiling point 188 degrees Celsius. Density 1.696 grams per 1. Neon. Atomic number 10. Atomic mass 20.1797 grams per. Oxygen. Atomic number 11. Atomic mass to 22.98977 grams per mole, melting point 987.81 degrees Celsius, boiling point 882.9 degrees Celsius, density 0.971 grams per cm. Magnesium 12 atomic number 12 atomic mass 34.305 grams per mole, melting point 650 degrees Celsius, boiling point 1.090 degrees Celsius, density 1.738 grams per cm. Aluminium atomic number 13 atomic mass 26.9815 grams per mole, melting point 660 degrees Celsius, boiling point 2467 degrees Celsius, density 2.70 grams per cm. Silicon atomic number 14 atomic mass 28.0855 grams per mole, melting point 1.414 degrees Celsius, boiling point 3265 degrees Celsius, density 2.33 grams per cm. Phosphorus atomic number 15 atomic mass 30.9738 grams per mole, melting point 44.1 degrees Celsius, boiling point 280 degrees Celsius, density 1.82 grams per cm. Sulfur atomic number 16 atomic mass 32.066 grams per mole, melting point 115.2 degrees Celsius, boiling point 444.6 degrees Celsius, density 2 grams per cm. Chlorine atomic number 17 atomic mass 5.4527 grams per mole, melting point 101 degrees Celsius, boiling point 34.7 degrees Celsius. Argon atomic number 18 atomic mass 39.948 grams per mole, melting point 109.2 degrees Celsius, boiling point 185.7 degrees Celsius, density 1.784 grams per mole. Potassium, okay. Atomic number 19 atomic mass 59.098 grams per mole, melting point 63.28 degrees Celsius, boiling point 760 degrees Celsius, density 0.862 grams per cm.
Conclusion. The periodic table is one of the most important achievements in the field of chemistry. It's full with patterns that help us better understand the world around us. Without it, we would not have many of the things and medications we have today.